This is day 8 of Advent of Cyber, and the challenge is called Last Christmas I Gave You My ETH. So before you start, download the task files. There are 2 Solidity files, and this challenge is based on blockchain vulnerabilities. So blockchain is essentially a decentralized ledger, and as I'm sure most of you know, the most common application for blockchain is cryptocurrency. As the title of this challenge suggests, it's going to be based on Ethereum. A component of Ethereum is the smart contract. Smart contracts are basically a decentralized way to perform a transaction, but it's not simply just the transferring of currency that the smart contract facilitates. The code within the smart contract can have predefined conditions within it, which when the condition is met, then the transfer of currency is made. There's a variety of different programming languages that can be used to write smart contracts. One of the most popular ones is Solidity, which is commonly used with Ethereum. So TryHack have an example of a smart contract, which we can look at here. So if we controlled contract A, and contract B wanted to first deposit 1 Ethereum, and then withdraw 1 Ethereum from contract A, contract B calls the deposit function of contract A. Contract A authorizes the deposit after checking if any predetermined conditions need to be met. So for contract B to deposit 1 Ethereum, contract B itself needs to have a balance of 1 Ethereum. So as contract B does have 1 Ethereum, it then deposits that 1 Ethereum into contract A. So now contract B calls the withdraw function of contract A. Contract A authorizes the deposit if the predetermined conditions for withdrawal are met. So for contract B to be able to withdraw 1 Ethereum from contract A, the balance of contract A must be not empty, which in the case here has 200 Ethereum. So it will then send the 1 Ethereum to contract B. Contract B can execute other functions after the ether is sent from contract A, but before that function resolves. So as smart contracts are programmable and they are created by humans, there's definitely going to be errors in the code. So with a lot of smart contracts, there are going to be vulnerabilities in it because of logical errors made by the programmer. So things such as not checking the balance of the contract, which would cause the contract to send more Ethereum than it should. There are a lot of vulnerabilities that can be exploited in these smart contracts. So here's an example of a re-entry attack. Assuming that contract B is the attacking contract and contract A is a storage contract, contract B will execute a function to deposit, then withdraw at least 1 ether. This process is required to initiate the withdraw function's response. So the function in contract A is that it requires a balance greater than 0, and it will send the account balance to the contract that requested the withdrawal, then sets the account balance to 0. And the attack function on contract B is that it requires a value greater than or equal to 1, it will deposit 1 ether, and then it will withdraw all ether from account balance. Note the difference between account balance and total balance in the above diagram. The storage contract separates balances per account and keeps each account's total balance combined. So we are specifically targeting the total balance we do not own to exploit the contract. So you can see at the top here, total balance 200 ether, and then the contract B balance is 1 ether. So at this point, contract B can either drop the response from the withdraw function or invoke a fallback function. A fallback function is a reserved function in Solidity that can appear once in a single contract. The function is executed when currency is sent with no other context or data. For example, what is happening in this example? The fallback function calls the withdraw function again, while the original call to the function was never fully resolved. Remember, the balance is never set back to 0, and the contract thinks of ether as its total balance when sending it, not divided into each account. So we'll continue to send currency beyond the account's balance until that total balance is 0. So we're now going to be going on to the actual practical part of this challenge. So if you're following along, go to this website here, Remix IDE. It's a website which allows you to work with Solidity code. So you go there, and if you have the files downloaded, you can go to here, open file, then add the files from here into Remix. So let's go to the challenge now. So download the zip file at the top, and then open Remix. So there are 2 Solidity files. There's attack.sol, then etherstore.sol. So when you add them in here, the compiler at the top here, you need to change this to at least 8.10 plus, because that's the version of Solidity that we'll be running. So let's compile them. So click compile, and they're compiling. That seems to all be good. So with the 2 contracts compiled, we will now go to this tab to deploy and run the transactions. So we'll first deploy the EtherStore contract. So we select that here, EtherStore, we'll click deploy. So with that deployed, here we can click the little drop down and we can deposit Ethereum into it. Actually what we need to do is put a value in here, so we'll put 10 in here and then we'll click deposit. Oh, I had the wrong currency, so we'll change that to Ether, then we'll put 10 and deposit. There you go, so the balance here is now 10 Ethereum. So now we need to deploy the attacker contract. So we go to here, contract, we select attack. We need to put the address of the Ether store Ethereum address in there. So go down here, click copy. We then paste that here, and then we deploy. And now we can see we've got both Ether store and the attack contracts deployed. So to perform this attack, what we need to do is expand the attack contract down here. We need to put a value of 1 into 1 Ether in this box, and then we click the attack button. So transact to attack is pending, and we can see here the attack contract now has 11 Ethereum, and the Ether store has only that 0.1 there. And we can see in the output that we've got the flag for the challenge, which is all your ETH is mine. So go back to try hack me, and we will paste that flag into here, submit, and that is day 8 of Advent of Cyber done.